Hi, I'm John Bevington, a geospatial technologist from ImageCat in the UK, and I have the pleasure of presenting an overview and discussion of building codes in Nepal. This has resulted from my participation in the EERI Learning from Earthquakes reconnaissance mission to Nepal to study the 25th of April earthquake and subsequent aftershocks. This talk is one of a series of presentations from the Learning from Earthquakes reconnaissance team, and I recommend that you watch the other talks which cover a broad range of perspectives on the Nepal earthquake. A number of these talks are very relevant to the topic of building codes, such as building performance and resilience, and these are highlighted here in purple. Building codes are a key issue for any seismically active area, whether a developed or developing country. They provide a set of regulations that govern the design, construction, or maintenance of structures to ensure earthquake safety for the occupants of those buildings. As the saying goes, earthquakes don't kill people, poor buildings do. Following a relatively low amount of attention in the Hyogo framework for action, especially in the area of code adoption and compliance, the recently published Sendai framework specifically addresses building codes as a method of investing in national and local risk reduction measures. This is not only the development of codes, but also the revision of existing codes and regulatory and practical methods to encourage and enforce the implementation of codes in a culturally sensitive manner. An appropriate and effective building code backed up by sufficiently robust implementation is critical for such a seismically active country as Nepal. A major problem for Nepal is the number of owner-built properties. Numerous studies, including the one shown here from 2000, highlight the prevalence of owner-built as the predominant type of construction, over 80% in urban and over 90% in rural areas. According to the Department of Physical Planning and Works of Nepal, only 5% of owner-built buildings have professional engineering design and supervision. Most of these structures follow the advice of local craftsmen and masons. The statistics presented here are for Kathmandu Valley, the most developed region in Nepal. This situation would only be exacerbated for more rural areas outside of the valley. Such a high proportion of owner-built properties means that great importance is placed on finding a suitable mechanism for governance, regulation, standards and enforcement. A building code exists in Nepal. The Nepal National Building Code is a relatively young initiative established following the 1988 earthquake, which killed about 700 people. A consultation process in 1991 led to the commissioning of an international effort to publish the Nepal National Building Code in 1994. The code was largely based on the Indian code of the time. It took until about 2003 for it to be approved by the government, with it being made mandatory only in 2006 for all municipalities, the largest urban developments in Nepal. However, no deadline has been set for implementation, which has caused several issues since. A review of the code took place in 2009, and a draft of the new code is now overdue, set for publication in mid-July 2015. As yet, in late July, no draft has been published, or is it available yet to the project team. Here is a summary of the Nepal Code. The code is aimed at covering the typical and most common buildings being constructed in Nepal. The hierarchy is around the sophistication of engineering input provided in the design or construction of a new building. Part 1 focuses on the international state of art. This addresses those points that should be taken into account by designers who wish to design structures for Nepal by sophisticated methods, more sophisticated than those described in Part 2. This is typically for the largest structures. Part 2 describes professionally engineered buildings. This contains the standard code requirements that professionally qualified engineers will recognize and must meet as a minimum when designing structures in Nepal. It covers structures such as hospitals, meeting halls, factories, multi-story buildings and residential buildings. The third part of the code is the mandatory rules of thumb, which focus on non-engineered, small buildings that have not had input from a professional advisor. The requirements are in terms of limits on spans, heights, minimum reinforcing, member sizes, etc. And finally, Part 4 provides guidelines for remote rural construction. This addresses about a dozen typical building styles prominent in rural areas. It provides diagrams and descriptions aimed at technical advisors, house owners, and laypersons. These guidelines emphasize the changes that should be made to traditional practices to improve the seismic resistance of new buildings that are not subject to modern quantitative analysis or rational design consideration. Several of the most pertinent seismic design considerations are summarized here. The code provides design requirements for plain and reinforced concrete, timber and aluminium construction. Professionally engineered buildings are largely based on Indian standards, which have subsequently been revised. Several elements in seismic design simply refer to the Indian code, such as detailing considerations. Force requirements, as well as technical detail on seismic coefficient method and model response spectrum method, are included. In addition, the code permits unreinforced brick masonry augmented with rebar at the openings, corners, and horizontal bands. The mandatory rules of thumb cover most of the predominant building types observed by the team in country, such as reinforced concrete, infill, and load-bearing brick and stone masonry. The mandatory rules of thumb provide guidance on detailing requirements and include some analytical requirements for RC infill frame, the most commonly observed structure type in Kathmandu Valley. Again, the MRTs also permit unreinforced masonry with similar augmentation as previously described. We had a number of initial observations whilst on the mission. Municipalities have a mandatory responsibility for issuing permits and ensuring compliance to the code for new construction. We found a low rate of adoption. Only 26 out of the 191 municipalities have begun the process of implementation. This was backed up by the literature, which showed at the point of adoption in 2003 that only 3 municipalities voluntarily adopted the code. Within municipalities, the picture is mixed as well. We have seen examples of public buildings adhering to codes with private buildings not. And this was apparent from the education sector, where private schools have little to no code compliance. In urban areas, some municipalities are leading the way, such as Lalitpur, and some are falling behind, especially those outside of the valley. In remote areas, there is almost no evidence that codes were being implemented widely, yet alone enforced. Since the mission, we've discovered that many of the bylaws enforcing the codes exist in municipalities, but are not applicable in the Rural Village Development Committees, the VDCs, meaning that people are using this technical loophole as a way of bypassing the code. There is a clear lack of regulatory framework to ensure code implementation. Resources are limited, particularly trained engineers, meaning monitoring and enforcement are ineffective. Visiting Nepal in a post-earthquake context also highlighted some of the issues faced. There is a disparity in damage between urban and rural. This was largely a rural disaster due to the further weakening of poorly constructed buildings by the main shock. The 12th of May aftershock devastated many villages and municipalities in the east. We saw examples of people repairing and rebuilding on site, often using old bricks and rubble as material, as shown in this slide. The official line was that these are temporary repairs. However, without a systematic capture of the damage data, it will be impossible to assess which buildings have been shorn up in this way, ultimately increasing vulnerability to future shocks. The monsoon was mainly cited as a reason for this. We heard examples of complaints about neighbours' repairs, with people concerned about the quality of repairs in their neighbouring buildings. So the demand for engineering advice was very high throughout our visit, with people in many areas not having received any trained assistance. I'll now go through a few examples from the mission relating to the wider code issues. Here is the Parkview Horizon complex, consisting of 213 apartments and one of the most severely damaged apartment complexes in Kathmandu. It consists of 5 buildings, each with 17 stories, and has numerous issues. High-rise buildings were particularly badly affected by the shaking from the main shock. The most prominent issue seen here is that the permit issued for these buildings was for a design of 12 stories, not 17. All 5 towers have been red tagged and declared unsafe by government inspection. These buildings are on the road to Chowtara. This is an example of the use of weak rubble stone infill on the bottom base story, noted in the red oval in the picture. This type of construction was seen in numerous areas, including on precipitous slopes such as seen here. It's not known the cause of failure of the collapsed building on the left, but issues such as infill or lack of geotechnical input may have contributed to the failure of this building. The third example is from a school in Sanku. This shows inappropriate detailing of concrete reinforcement. The top left image shows the front facade of the school. Several columns are like the one in the oval. There's a blow up of it on the left and a blown up further on the right. It shows a 90-degree hook in the red circle, wide tie spacing, well over D/2 and even approaching D, and no cross tie on the middle vertical longitudinal bar, which is shown here in the yellow circle. This standard of tie spacing was seen in other locations and is essentially of very limited to no value at all. The final example is from a rural area to the east of Kathmandu. Here we met with a very inspirational lady, a homeowner whose 5-story house suffered collapse of the upper 3 stories. The permit for the house was originally for a 2-story building. She told us that she had used her own savings to demolish the unpermitted upper stories and that her aim was for the next 5 generations to remember not to build on top of the house in the way it had been previously. In terms of the adequacy of the code, a number of general observations were made. For new buildings, a risk-targeted approach to design by incorporating ground motion in the design process would provide a better level of seismic safety. Provision of guidelines for dealing with geotechnical issues such as site amplification, liquefaction and ridgetop amplification are all warranted. And there is no current provision for disabled access. A large issue for existing buildings are the lack of standards or guidance for retrofitting existing structures. After the earthquakes, it's clear that there is a lack of guidance on repair or retrofitting, as well as no guidance on safe demolition of damaged buildings. Revisions to the code are overdue, but the content of these has not yet been revealed. Some technical issues have also been identified. For seismic design, adequate description of irregularity will give a clearer picture of the effect of soft story. Provision of more detail on the effect of infill masonry should be a priority area of improvement, particularly the specifics of strut infill and the dynamics of the impact of a strut on concrete frame. Additional information on concrete design, such as cantilevered slab or pre-stressed concrete, should also be added. International codes would provide a useful reference to benchmark the detailing of steel reinforcement. There are a number of additional recommendations which can be found in a 2009 review of the Nepal Building Code. This was published by the Government of Nepal. You can find this in the reference section. Housner and Jennings back in 1982 reminded us that it's not economical to design every structure to resist the strongest earthquake without damage, but there are clear areas of improvement for the National Building Code of Nepal. Occupancy should be taken into account for occupancy load, for change in occupancy, and performance-based design for specific occupancies, such as hospitals, schools, etc. Usability should be at the center of the code. It should be a target to have safe and usable critical facilities after an event, including generators and utilities. Housing should offer shelter in place, perhaps even yielding on utility provision. A key point not addressed is the appropriate planning of urban centres, which we saw little evidence of in Nepal. These plans should afford safe access and egress and provide usable public spaces for temporary refuge, aid distribution, or even debris removal. Critically, the building bylaws are, by legislation, applicable in the areas of jurisdiction of the municipalities, yet they do not include provisions for the Nepal Building Code. Most of the rural areas are not covered by the Building Act and the building bylaws. Municipalities such as Lalitpur have voluntarily initiated the application of the NBC back in 2003. So therefore, expansion of the building bylaws should be legislated to close off these loopholes for rural construction. The end goal for all of this is to increase the overall resilience in Nepal. There are plans to revise the building code, including additional emphasis on seismic design, as noted here in one of the English language newspapers. This has been ongoing, and we should note that this is not a reactive measure to the recent earthquakes, and this is evidenced by the 2009 report from the Government of Nepal. The earthquake has focused the minds of the government and the public to the issue of building codes. There have been several community-focused activities to promote the implementation of the codes, and the enhanced awareness has promoted this issue to the public consciousness. But my question is, for how long before the human memory fades? There is a role for the engineering community to develop basic guidelines, do's and don'ts, to aid the repair and the retrofitting processes. Workshops to develop local capacity have been very well received to date. The programs led by NSET, the National Society of Earthquake Technology, should be given due acknowledgement as positives in Nepal. Several of these are ongoing and involve international cooperation. The NSET project with USAID and the Office of Foreign Disaster Assistance, the Building Code Implementation Project, targets 24 municipalities to develop local mechanisms to further advocate code adoption and compliance. And these focus on earthquake awareness, local training, and capacity building workshops. It's clear that there are very strong relationships between NSET and their implementing partners in the municipalities. In Dolakha, for example, after the earthquakes, the municipality donated land to develop Reconstruction Technology Centre, where local masons and engineers can receive training in appropriate repair and reconstruction practices. All of these activities build on the ongoing public awareness efforts of NSET, including the regular mobile clinics and the annual Earthquake Awareness Day. The ambition to challenge and improve the technical detail of the building code is welcomed, and it's mainly driven out of the Department of Urban Development and Building Construction, part of the government. It is hoped that the new draft code will be published soon and be available to review. Other positives should be noted, such as the school retrofit program outlined in the Building Performance 2 presentation by Brett Luzundia as part of this series. At the forefront of the code issues in Nepal, Lalitpur municipality has been working on a UNDP-backed program to automate the building permit process. Additionally, from anecdotes, we heard of the desire to remove additional stories in several municipalities, as well as locals complaining of the standard of their neighbours' repair. signs indeed of heightened awareness of the issue of poor construction due to the earthquakes. The LFE mission to Nepal feeds into the ongoing group project of the EERI Housner Fellows Programme, in which I participate. The Housner Fellows will continue to focus on the issue of building codes through their group project, Strengthening Building Code Compliance in Developing Countries, a case study of Nepal. This project has focused on the low and mid-rise residential structures in 3 municipalities inside and outside Kathmandu. The project largely concentrates on issues of code implementation, compliance and enforcement, rather than a pure technical analysis of the strengths and weaknesses of the code. So we aim to have additional data collection effort in fall 2015 and plan also to elicit input from the wider EERI community in a forthcoming survey. Please email us at housner2014@eeri.org for more information on this project. To conclude, there are tandem issues of code adequacy and code implementation at play in Nepal. Technical improvements to the code are overdue, and evidence of compliance is low, especially outside Kathmandu. The recent earthquakes give an opportunity to exploit the increased awareness of the code and code issues for the government of Nepal, the wider public, and the international engineering community. However, there's a finite window in which to take action to really capitalize on this. There's hope and evidence of many valuable initiatives and very promising initiatives that promote the appropriate use of codes and promotion of code issues. And as part of the EERI Housner Fellows Programme, we will be continuing this study and hope to have make a positive contribution to the ongoing debate on code issues in Nepal. More information can be found in these reports and documents. Additionally, some great information, field data, reports from the reconnaissance mission can be found on the EERI Earthquake Clearinghouse, and the link is shown. And it includes over 10,000 geolocated photos, as well as reports and topic posts, and this is going to be expanding over the next weeks and months. So my personal thanks and appreciation goes to my virtual collaborator, Diane Moog, who carried out supporting research before the trip and also uploaded field data to the clearinghouse map. I'd like to also thank the following individuals and organisations who supported this effort: EERI's Learning from Earthquakes programme, NSET for coordinating and doing everything in country to make our life much easier, the Learning from Earthquakes team members for their broad perspectives that challenged and grounded our views on building codes. I'd like to thank the 2014-16 class of Housner Fellows for their continued collaboration and camaraderie. But mostly I'd like to thank the numerous individuals, agencies and groups who donated their time, their experience and spoke to us when we were in Nepal. Particularly for this presentation, I would like to provide thanks to Chris Poland, Brett Lazundia, Surya Stretha and Kishore Jaiswal, as well as Fred Grimgold from Virginia Tech, each of which provided input to this presentation.